Right, fam. Video number 2 of the day. Let's get going. Mod 17B quiz review. This is the perimeter and area section. A little bit shorter, but maybe a little bit longer because you actually have to do some real thinking here. Here we go. So we are doing perimeter. As a reminder, perimeter is all the way around the figure. So you got to do all the way around. So doing that, we're going to go ahead and notice that the 7 is going to line up over here. There's a bunch of these little 2's put on over here. And then this side up at the top has to be 2 plus 5 plus 2. My voice sounds weird because my headphones are strange. I don't know what's going on. I'm going to pause. All right, hopefully we're fixed up. Okay, where did my pen go? Here it is. All right, so we got 2 plus 5 plus 2. That's going to give you 9 over at the top here. And final answer, you just got to add everything up. Feel free to shorten it up. You know, if you want to do something cool like, uh-oh, my camera's frozen. You can't see anything that's happening. I'm going to restart this video. It looks like... Nope, don't have to do it. We just scrunched up the nose a little bit and, you know, stared the computer down and it decided to start working again. So we got a few things coming up. Anyways, what was I talking about? So we got 2 plus 5 plus 2 equals 9. We got the 7, the 7. We got the 2, the 2. We got all these 2's over here. And what I was trying to say is you could shorthand it if you felt like it. So I'm going to do it the long way first. So we got 7. I'm just going to go kind of clockwise starting at noon maybe. Let's go. So we got 9 plus 7 plus this 2 plus this 2 plus the 5 plus this 2 and this 2, 2 more 2's plus another 7, and then you just add all those up, right? So that's method number 1. Let's just see. So that's 16, 20, and then 29, and 7 is 36. That's method 1. That's totally cool. And we got centimeters. Or method number 2 is just kind of multiply where it's appropriate. So there's only the 1, 9, but there are 2 7's. There are 1, 2, 3, 4 2's. And then there's 1, 5. And just to verify it, we're going to show in our calculator here, we get the same number. We're going to do 9 plus 2 times 7 plus 4 times 2 plus the 5. Boom, we also have 36. So you can see these 2 different methods. You pick your favorite, whichever one makes you happier. I don't really care. Get you the same answer either way. Let's go. Determine the perimeter of this thing, the circumference of the following figure, noticing that we have a little 90 degrees. So again, 2 different methods here. Method number 1 is noticing that this guy right there is 90 degrees. Because we know that's 90 degrees, we can use our formula from the previous page there, or the previous assignment, which is going to be 90 over 360 multiplied by 2 times pi times the 4, and that will give you the correct answer. If you type all that into your calculator, remember you're skipping the pi. You don't write the pi in there, and you end up getting looks like a 2 pi is your final answer here. However, you could have also noticed just by kind of glancing at it, hey, that's 1/4 of a circle. But if you notice, this 90 over 360 is 1/4. So if you just wrote 1/4 in the first place, you'd get the same exact answer. I don't really care which way you do it. Yet again, 2 methods, 2 problems. Let's keep on moving. Now we are going to area. So make sure you're careful here. It says area, use our formula length times width. You got to go ahead and divide these shapes up into the correct sizes. So I'm going to do this division here. I think that's the most obvious version of it. But we do need to figure out what this length is right here. So this length right there is, in fact, going to be 7 minus, and you're subtracting away both of these 2's. So it's minus 2, or minus 2 times 2, whichever one makes you happier. Turns out 7 minus 2 is 3. So our area here, this one right there is going to be 2 times 3 to get 6. And this is going to be 14, which comes from 7 times 2. And our area finally is going to be those 2 things added together, which is going to be, 20. And this is centimeters, and it's going to be squared because it's area. So yet again, I don't really care about units, but your teacher does, put them in. And it's good habit, good practice if you're planning on going into some stuff like AP Calculus later in your math career. Pausing real quick. All right, I had to pause for a little bit. Got a phone call in the middle of that thing. All right, let's get back going into this. Determine the area of the following triangle. Use our 1/2 base times height. So the key here is we have to figure out what this length is here, this dotted line, because that is our height. I was more specific in my class and even said that we want that height perpendicular, that little upside down T in there. So the key to doing this one is realizing that we have a 3 here and a 3 here because it is 6 divided by 2, and therefore we have our beautiful 3, 4, 5 triangle. So that means that this height over here is 4. Our area is therefore 1/2 times our base of 6 times our perpendicular height, which is 4. Put all of that into your calculator and you get 12 centimeters squared. Boom, boom, boom. Keep the ball rolling. Let's do it. Over here, got to figure out what this guy is over here. This is our height. Remember, our height is perpendicular. It has to have a right angle. We need to figure out what that is. We could use sine in this problem, but it's actually easier to remember our special triangle. Our special triangles are 45, 45, 90 triangle, where we have an X, 45 in both corners here, and an X rad 2. So in my mind, I think it's really, really obvious that in this case that X is in fact equal to 4, and that's what we're looking for. That means our height is equal to 4, and our area is going to be a 1/2 times our base of 7 times that height of 4, and half of 4 is 2, and 2 times 4 is 14 centimeters squared yet again. Let's do the back side. We only got 5 more to go, and then we're done. Boom. Here we go. Question number 6. Determine the area of the trapezoids. In my class, I used h over 2 instead of having the h over here. This is actually the more classical way. It's the way I learned as a kid. But in my class, I was having students do h over 2 multiplied by base 1 plus base 2. That's what a lot of the modern textbooks are doing. All right. Anyways. So our area here, we have to figure out what our height here is, our x. For our height, in order to do that, we do need to remember our 30, 60, 90 triangle. So our 30, 60, 90 triangle is going to look like this, a 30, a 60, and we're going to have an x over here, an x rad 3 over here, and a 2x. And the way that I personally remember this is that the rad 3 is always right next door to that 30. The 3's kind of chill together. The 60's all by its lonesome over there, and a 2x on the hypotenuse. Either way, on this one, we're going to go ahead and say that 2x is therefore equal to 8, and therefore x is equal to 4. And that is what we really wanted to know in this question. We have a 4 over here for our height, so our area for this problem must be 4 over 2 multiplied by our base 1, 10, our base 2, 2, and throw that bad boy into your calculator, and you will get 24 centimeters squared. Yeah, let's move on to question number 7. And we have yet another special triangle, our 5, 12, 13. Hopefully we have these memorized at this point. We got a 12 there. That means that this is a 12 over here. And if these two are the same and that's a right angle, that means this is a 12 as well. And if those two are the same and it's a trapezoid, that one's a 5. Finally, the entire base, you got to add all those together. Here we go. Maybe I should like draw a little thing in between these questions too. Okay, because that 12 is going with this one, whatever. All right, our area is going to be our height, which is 12 over 2 times our base 1. Our base 1's at the bottom down here, so we're going to have a nice 22 for our base. Did I say 19 earlier? I think I did. Someone correct me, but it doesn't matter because I corrected myself when I actually had to write down the answer. Our area is therefore going to be 32 times 6, which is 192. Kind of want to double check my own work there. No, it's a 216. What am I doing? Mr. Richards, get it together. What am I? No, 24. It was 24. I had it right. I had it right. 34 times 6. No, it's 204. Still wrong. What did I do? I am going crazy here, guys. 204 is our correct answer. I knew I should have checked my work. This is why I checked my work, because I was a little bit off kilter from the other stuff, and it's okay. Equilateral right triangle, here we go, our 60 degrees everywhere. Because we have our 60 degrees everywhere, you can use this formula like I was saying in class as well. This is typically written as rad 3 over 4 times our squared side, but either way is okay. We just got to throw our side of 6 into that equation. So square root of 3 over 4 times our 6 squared. 6 squared is 9, 36. 36 divided by 4 is 9. So we're going to write our final answer is 9 rad 3. When you plug this into your calculator, just like we were doing with pi on the last one, you want to make sure that you're plugging it in as a 1. So if you notice, it did 1 over 4 and then 6 squared, and that gives us the 9. So I can get this perfect answer here. So I'm going to write this over here. Make square root of 3 a 1 on calc. That reminds you that you're turning into a 1 when you're actually doing this question. So you can get the correct answer when you plug everything in. If you wanted to, you could decimalize this one, but I really don't like the decimal version. We want the square root version in our answer because that's what it's going to be like on that ACT. Number 9, determine the area of the following hexagon. We didn't do this in class. What the heck? All right, well, I guess we have a bonus question. Bonus! All right, 3 over 2 s squared times r squared of 3. Why did I write it again? It's right there in front of me. Oh, because I would usually write the rad 3 with the 3. If I was doing this in class, I would do it like this. Okay. Anyways, we do need to figure out our side length. We need to figure out our S over here. That's what they were talking about. I think the slight literally actually might be a bonus problem. I just let you guys have 1 extra point if needed, and then you can't have extra credits. So you can't go over 100, but like it like takes over 1. I don't know. I'll make that decision eventually. All right, so we have a 30 degrees, just like before. We have our 30, 60, 90 triangle, and our 30, 60, 90 triangle across from the 30 is our x. Right next door to our 30 is the x rad 3, and then we have 2x. I think it's nice and obvious here that the x in this question is going to be a 4, which makes this a 4 down here, which makes the entire dang length 2 times that, which is 8. Another way of imagining this is that we know that this is 8 from our 2x here, 2 times it, and it's a equilateral triangle. It's a bunch of 60 degrees, so they're all going to be 8 all over the place. And you can kind of like connect it to this one up here where we had like this formula here, and you just take that formula and you multiply it by 6, and if you multiply it by 6, you get this formula, which is, I don't know, this is where this is all coming from. It's all coming together here. Our area, we have 3 rad 3 over 2 times our side length squared, 8 squared, and then our area, throwing all that into our calculator, 8 squared, you see what I'm doing? I'm just going to do it like without all the fractions. I did 8 squared divided by 2, and then times 3, got 96. We got 96 rad 3, and again, you could have done the entire thing all in one step. We still want to have our square root in our answer, centimeter squared. Very good. Here we go. Very last one. So it tells us in the problem that these are perfect circles. So there, it looks like there are 2 circles and the square. So the inside of the square, I think, is obviously 100 because it's 10 times 10. Maybe I should write that. We have 10 times 10. And then each one of these little bad boys is going to be 5. So the area of a circle here is going to be pi times 5 squared, which is 25 pi. But there are 2 of those circles. So our area is going to be 25 pi plus another 25 pi plus 100. And normally we actually write pi at the end of these questions. So we're going to write 100 plus 50 pi, put that in parentheses, put our centimeters squared on it, and we're done. Peace out, guys. Have a great rest of your day.